All right, so we're going to do a second example of ANOVA just to try to reinforce some of the concepts. So I doubt you really want to listen to me read all of this to you, so I'll let you pause the video and read through this example. But the main idea here is that we're selling electronics and we want to see which location in the stores perform the best in terms of sales. So we've got 4 locations. That's in the aisle, in the front, at the kiosk, and the expert desk. And you can see we're just looking at sales. So we've got these 4 locations, and we want to see, okay, do sales depend on where they're located in the store? So we can see in aisle seems to be the lowest, front seems to be the best. I suspect there's a difference between an aisle and front, maybe an aisle and kiosk as well. And in fact, front looks pretty different from everything. So we should expect to see some significant results here. And we'll dive into which ones differ at a significance level. So when you get to the Excel lab, we will produce all of the ANOVA tables, but in this video, we just kind of want to streamline some things. Really, the goal of this chapter is the ability to read the ANOVA table. So we make this in the Excel lab video, and so we've got our ANOVA table right here. And let's just work through this process again. So let's start with our hypotheses, which is that our average between the 4 locations will be the same. So I'll do mu A for aisle is equal to mu F for front is equal to mu K for kiosk is equal to mu E for expert. And then the alternative hypothesis is that the null is false. At least one of these are different from one another. Step 2. We're going to just keep using alpha equals 0.05, and our n here is 20. So if we go back to the problem, we've got 20 locations. So we're going to divide this 4 groups of 5 stores each. So we've got five observations here, 5 here, 5 here, and 5 here. So 4 groups of 5 make a total of 20. So the next step would be to check our 3 assumptions. So this would involve, let's see, independence. So we are randomly assigning goods to each of these locations. So I'm randomly putting some in front at kiosk, expert, and so on. So yes, they're independent. Are they normally distributed? Whenever you only have 5 observations in each group, you really can't even test it. So we'll just have to make that assumption. I mean, this one looks a little symmetric, same with these, but we really don't have any way to check that. And then what's our third hypothesis? I actually forgot what our third one is. And I apologize, I am not prepared. Equal variance, that's right. Well, they don't really look equal. I mean, look how tiny the variance is on this one versus compared to an aisle where the variance is much larger. So, it's hard to say. Whenever you have observation or such a small sample size, it's really hard to check these. So I think the important thing is that we just acknowledge what the 3 assumptions are, which is just one, yes, they are independent. And then let's just list the other 2. So normally distributed, and 3 is equal variance. So the second and third assumptions maybe don't hold, but we'll list them just so we know that they are supposed to hold true. But let's just go ahead and move on. So 4th step is to calculate F-stat, which let's go to our ANOVA table. So again, this was done in Excel. We can see we get an F-stat of 16.99. So F-stat is 16.99. the fifth step, so our rejection region is F stat, F stat bigger than F critical. So let's look at our degrees of freedom. So we have four groups. So we have 3 degrees of freedom for between or among groups. We have 20 observations. So we have 16 degrees of freedom for within groups. So we have F, 3, 16, and then 0.05 because we're using alpha 0.05. So if using our Excel formula, we get an F critical value of 3.24. And then step 6, so F stat, and again, this 3.24, I should back up. Where did that come from? That comes from right here, our F critical value. So F stat and F critical. So F stat is equal to 16.99, which is bigger than 3.24, which is our critical value F, 316.05. And if we wanted to calculate the p-value, that would be equal to the probability of F, 316 bigger than our F stat of 16.99, which is equal to 0.001, which is less than 0.05, which is our alpha. So according to both of these rules, because F is in the rejection region and because our p-value is less than alpha, we definitely reject the null hypothesis. So reject H naught and accept HA. So we could say there is enough evidence to conclude that at least one pair of store locations mean sales differ at the alpha 0.05 level of significance. Okay, so not too surprising, we reject the null hypothesis. Looking at our box plot, that we can see there are some pretty big differences between these groups. So now, of course, we need to determine which groups are actually different from one another. So we're going to move on to the Tukey-Kramer procedure. So again, this is done in Excel so that we can kind of streamline this for ourselves right now. So we start with our hypotheses. So we're just saying that each pair of means are equal to each other, and our alternative is that they are not equal to each other. So mu j not equal to mu k for j not equal k. 2, we always stick with the same alpha, so we have alpha equal 0.05. 3, so our CR, so critical range, so we can see that's right here, and we get 0.9993, so 0.9993. So that required us to calculate the standard error and get this Q value from online so that we can get our critical range. But we don't need to do these calculations by hand. We're just going to keep using Excel. And then for our rejection region will be wherever mu j minus mu k bigger than CR, which in this case is 0.993. So let's just quickly see which ones are bigger than that. So that would be here, here, and here. Right, those 4 values are all bigger than 0.993. 993. So we can see it's this group, this group, this group, and this group. And so I actually already wrote this down. So we can see from our table, we can conclude that the following locations yield different mean sales at the alpha equal 0.05 level of significance. And we're comparing in aisle to front, in aisle to kiosk, front to kiosk, and front to expert. And we should just double check that those make sense to us. So does it make sense that an aisle is different from front? Yes, it does. What about an aisle to kiosk? Yes, it does. The box plots are almost not overlapping at all. And then expert, I wouldn't have been surprised if it was different or not. In this case, they were not. So not surprising there. And then we saw front was different from kiosk and front was different from expert. That makes sense. Front is much higher than everything else. Maybe that makes sense because when you first walk into the store, it's going to be the first thing you see. And then there is no difference between kiosk and expert. We can see they are quite similar to one another. So it's always good to give yourself a reality check to make sure that your findings make sense. So anyway, that is just another example as to how we do this ANOVA procedure.